This is Algebra 1, Unit 10, Lesson 7 on linear regression on the calculator. So what we're going to be looking at is using bivariate data, which is two variable data, and graph it on a scatter plot. That's what we're going to be looking at. And we're going to use the calculator to do the scatter plot. And we're also going to use our calculators to find the equation of the line of best fit. This is called linear regression. It's a line that goes through the data that we use to make predictions based on the data. All right, so before we start, I need you to get out your calculator, and we're going to front load the data in this so that we have all the data in so we don't have to keep stopping. All right, so for exercise 1, put this one in L1, this one in L2, and on the back of your paper, in exercise 2, put this data in L3 and this one in L4. So go ahead and pause the video, and you can go ahead and put that data in. When you're done, come back. Okay, so the first thing that we're going to do is we're going to create a scatter plot. So in exercise 1, a survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and high temperatures. So these are the low temperatures and high temperatures, and we want to see if we can make a prediction based on our data. If the low temperature is such a thing, then the high temperature is going to be this other value. All right, so we want to enter the data into list in your calculator, which you already did. And now we want to create a scatter plot. All right, so on your calculator, you want to turn your stat plot on. So you press second y equals, and that takes you to your plot. All right, so you press enter. We want plot 1. The first thing we want to do is turn it on. So you want to put your cursor on here so it's blinking and press enter. That turns it on. All right, then make sure you're on the scatter plot, which is the first one. If you're not on the scatter plot, just move it over so you are. And then make XList L1. If you need to make it L1, it'd be second 1. And then L2 would be second 2. And then the mark in the blue is fine. All right, now normally what we do when we do a scatter plot or when we do a graph is we adjust the window so it fits. So what we're going to do, first of all, is use a zoom key in order to do that. All right, so to use the zoom key, that will automatically fit the window to the data that you have. So if you press zoom and then number 9, zoom stat, you can see zoom 9, you have created your scatter plot. So let me write that down so you know what we did. All right, so the scatter plot, you had to turn it on by pressing second y equals, that turns it on, and then you adjust the plot as you needed to. And then to size the window, you press zoom 9, and that will give you the window so you can see at the majority of the screen. All right, so we're not doing the last lesson, so don't worry about the rest of that. So we have created our scatter plot. It looks like this. So this is all the data graphed, and what we're looking for is what's called a line of best fit. We want to figure out where the line would be in here that will fit the data so that we can make predictions based on what our data is. All right, so that's what we're going to do now. We're going to use the calculator to find the equation for the line of best fit. All right, now to do that, it's on the stat calc thing again. So it's going to be stat calc again, stat calc. But instead of using var stats like we did previously, we're going to use linear regression, which is number 4. So stat calc number 4, linear regression, because notice it's ax plus b is not the equation of a line. That's what we want. So we want number 4. All right, my x list should be L1, second 1. My y list should be L2, would be second 2. And then go down to calculate, press enter. And here's the equation of a line, y equals ax plus b. A is the slope, b is the y-intercept. So we had just created a new line. So let's write this down. The equation for the line of best fit, it gives you the equation ax plus b. They use a instead of m. All right, all we have to do is plug in the a and the b. It says, use your calculator to find the equation for the line of best fit. That's the regression. So that was stat, calc, and then number 4, linear regression. That's what we wanted. Okay, and it says round the slope of the line to the nearest hundredth. The slope was a, so that's going to be 1.16. And b is going to be rounded to the nearest integer, which is the nearest whole number, which is the y-intercept, is going to be 19. All right, rounded to the nearest whole number. All right, so the equation of the line is y equals 1.16x plus 19. So don't worry about this. All right, so what we are saying is if we are making predictions based on that data, this would be the line where we make the predictions. So explain what the y-intercept of this model represents in terms of the low and high temperatures that are being modeled in this problem. All right, so the b value in this case is the y-intercept is 19. Okay, where is the y-intercept found? It's when x is equal to 0. That's when you find the y-intercept. Well, x in this case is going to be the low temperatures. So this is saying when the low temperature is 19, or is 0, I'm sorry, which is x, is 0 degrees, the high temperature will be the y-intercept, which is the y, will be 19 degrees. So when the low is 0, the high is 19. That's what the y-intercept is saying for this one. Okay, now, how would you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? All right, so our slope for this one was 1.16. All right, now remember, slope is really rise over run, change in y over change in x. All right, now the x is the low temps, and the y is the high temperatures. So as the low temperatures increase by 1, which is the x, what does the high temperature do? Well, it's going to increase by 1.16. Which is y will increase by 1.16. All right, so if we go to our calculator here, if I go to y equals and put in my equation 1.16x plus 19 and graph that, you can see the line of best fit will go right up through this data like so. And you can see as the x's are increasing, the y's are increasing as you go up, and it's going to go up by 1.16 every time we increase by 1. All right, and your y-intercept right here is going to be 19. So you can see how that goes. All right, so that is the line of best fit. All right, so now let's look at the second exercise. Generally, the fuel efficiency of a car changes with the weight of the car. A survey of some cars with their weights and gas mileages is shown below. All right, so this is the weight and this is the mileage. So we already have the data in here, so let's do the equation of best fit. All right, so I'm going to go to Stat, Calc, and then number 4. All right, my data is in L3, so second 3 and second 4. There's my data for x is 3, y is 4, and then go down to calculate. All right, so here is my y equals ax plus b. And it says round both coefficients to the nearest tenth. So a is going to be negative 8.1 and b is going to be 68.1. So the equation is going to be y equals negative 8.1x plus 68.1. That's the equation of the line of best fit. All right, now list what the variables x and y represent in this problem. X, according to this, is the weight of the car in thousands of pounds. All right, now notice this says thousands of pounds. So if this says 3.7, how many pounds is that actually? Well, 3.7 is actually 3,700 pounds because that's in thousands of pounds. 3,700 is 3.7. So instead of having to put the whole big number in there, they're just using decimals. All right, and then the y is going to be the mileage, the miles per gallon. How many miles per gallon the car gets. So when the car weighs so much, it gets so many miles per gallon. That's what we're comparing. All right, now we want to create a graph of the scatter plot for this data. All right, so we want to go to y equals, first of all, we're going to clear this out. All right, let's put in our new equation we just found. It was negative 8.1, y equals negative 8.1 x plus 68.1. And then we want to go to our plot, second y equals, go to plot 1, make sure it's on, type, we want x list to be L3, second 3, y list will be 4, second 4, and then just hit zoom 9. So there's the scatter plot, and there's the line of best fit that fits the data. All right, so there is our scatter plot. All right, now, what they're asking is, would you consider the correlation between weight and mileage to be positive or negative? And explain. All right, so what they're asking is, as you move left to right, as the x's are increasing, what are the y's doing? What is the correlation here? Well, as the x's are increasing, what are the dots doing? They're going down. All right, so as x increases, y decreases, so that means it's going to be negative. As the weight, which is the x, increases, the mileage, which is the y, decreases. So that means it's going to be a negative correlation between that. So the relationship between them is going to be negative. As x increases, y decreases. All right, so which parameter of the linear model? Is it going to be the slope or the y-intercept? It would be the slope, because the slope is negative. The slope is negative, so that tells us the correlation is going to be negative. As x increases, the y decreases. So in this case, as the weight increases, the mileage decreases, makes it negative. So that's going to be your correlation. Okay, now let's use the line of best fit to make a prediction. If a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency? All right, so using the line of best fit, negative 8.1x plus 68.1. The car had a weight of 4,300 pounds. Is that an x or is that a y? That's going to be an x, okay? And it has a weight of 4,300 pounds. Remember, it's in thousands of pounds. So what do we plug in for x is going to be 4.3. So if I plug that in here and calculate what y is, I can figure out what the mileage is going to be. So negative 8.1 times 4.3 plus 68.1. So 33.27 is what I got. And it says round it to the nearest integer. So that's going to be approximately 33 miles per gallon. Okay, so that means a car that weighs 4,300 pounds will get 33 miles per gallon based on our data. That's the prediction our data is making for us. Okay, so then the last one, if we wanted to purchase a car that got 40 miles to gallon, what weight of car to the nearest 100 pounds should we purchase? Solve algebraically. So we want to use our equation of our line of best fit again. And this time, 40 miles per gallon is a mileage. So that is a y. So we're going to plug that in here. And we're looking for the weight of the car, so we're trying to find what x is. So we just need to solve the equation. So we subtract the 68.1, and that comes out to be negative 8.1x is equal to negative 28.1. And then we divide by negative 8.1 and take my word for it because I'm running out of time. X is going to be 3.469. So to the nearest 100 pounds, this is about 3,500 pounds because this would be about 33.5, which is about 3,500 pounds. Okay, so the car will weigh approximately 3,500 pounds when we do this. When it gets 40 miles per gallon, it predicts the car weighs 3,500 pounds. So that is lines of best fit and scatter plots for your calculator.